So hey guys, my name is Ankit Singh, student of BE Computer Science and Engineering, and today we are going to discuss about multiple access protocols. So guys, before going to the types of multiple access protocol and further details, first we should know about what is multiple access protocol. So it is present in the data link layer, and actually guys, if we want to communicate between two nodes or two computers in the entire lecture, if I say nodes, it means two computers. So if the communication occurs between the two computers or two nodes, so it is very simple that we know all that one will send once at a time, one will send message, another will wait for reply, and then it will receive the message, it will read it, and it will again send the message. It is simple in the peer-to-peer or one-to-one networks. But when it comes about multiple computers or multiple nodes, especially when they are computed with a single channel, so there may many chances that there may be collision can occur. Collision means when two nodes simultaneously tries to access the network at a time. So here we are going to resolve that problem using multiple access protocols. So here's types of multiple access protocols. So there are basically three main categories with the help of which we can solve this problem. First is random access protocols, in which we are going to discuss the entire session in details. And then the second is controlled access protocols, where we use some methods like a reservation, polling, and token passing. And the third is channelized protocols, where we use FDMA, CDMA, and TDMA. So the FDMA is nothing but frequency distribution multiple access. TDMA refers to time distribution multiple access and all. So the random access protocol. The random access protocol is nothing but where the access to the channel to a node which we give into a channel is very random. Like we are suddenly selecting any node at a time and it will send the message at the node. So, and the decision is totally depend on the medium only, whether it is idle or busy. If the medium is or the channelized medium is busy, then entire node will wait till it will get free. And there is no scheduled time for any station to transmit. The transmission is random among the stations. That's why these methods are called random access. So the reason is given here why it is called random access, and there is no specifying rule which to send the text message to the next nodes. And as I told you the definition of collision, if more than one station tries to send the message at a time, then their access is conflicted, which the conflict is known as collision. So there are mainly four division in this random access protocol. That is Aloha, CSMA, CSMA-CD, and CSMA-CA. And the Aloha is further classified into the pure Aloha and slaughtered Aloha. So guys, here we are talking about Aloha Protocol. The Aloha Protocol was developed in 1970s at the University of Hawaii. The basic idea is simple. Let the user transmit whenever they have data to send. And it's very random, like whenever you have data, you can send on the channel. If it is busy, you can wait till then it gets free and you can send. So if two or more users send the packet at the same time, a collision occurs and the packet is destroyed. So the data loss occurs here, like the when collision happens, the data loss will occur. It's fixed. So the Aloha protocol, the original Aloha protocol is also known as pure Aloha, and each station sends the frame whenever the frame has to be sent. And however, there is only one channel to share them. There is only one like medium where we can share the data. If two or more stations transmit at the same time, there the collision will occur, and the sender waits for the random amount of time till it sends the message again. And the waiting time must be random. Like first you can wait about 10 microsecond, 10 millisecond, and 100 microsecond. Like it can be random only. So here's the diagrammatic representation. Like there are four stations sending message random at the random times. So the collisions for in the first frame 1.2 and 2.1 and 3.1, all these are in the collision durations, and but 1.1 and 3.2 is not in collision range. So with using this formula, we can calculate the uh, efficiency of our Aloha channel, where S is equal to G into P naught, where S is the throughput and G is the median regenerated and new frames, and P0 is the probability that the frame does not suffer. So there is slotted aloha. The slotted aloha, we divide the time into the different slots. Like it's like aloha only, but we divide the entire channel or the sending time into the time periods. So So the slotted ALOA we can represent in this time frames. You can see that we can control, like in the previous diagram, we can see that the half of the 2.1 or 3.1 was in collision range, but here we can, when we divide into the time ranges, we can see that maximum like 1.1, 2.2, 3.2, and 4.2, like 4 frames are out of collision range. At that time, only 2 frames were out of the collision. So the efficiency of the slotted ALOA we can calculate by using this formula. So now we are going to talk about the second classification of random access protocol, which is carrier sense multiple access protocol. The CSMA was developed to overcome the problems found in Aloha, that is minimization of chances of collisions. As to improve that model, the CSMA protocol was based on principle of carrier sense. The chances of collision was to be reduced at greater extent as compared to Aloha. So it is a time-space diagram of CSMA. Now there is one persistent CSMA, like it's the classification of CSMA, where it will check the medium whether it is busy or it is idle. If it is busy, it will again check the medium again and again. When the medium gets free, it will send the message. Like message, it will first will send acknowledgement. If an after some time, if the acknowledgement is not received, the time when the time out in the way random amount of time, then it will go again check the medium. So there is non-persistent CSMA also. It's another classification where actually first it will check the medium, and if the medium is busy, it will wait for some time before sending, and then it will again send the medium till it will repeat the process till the medium gets free. When the medium is free, it will again send an acknowledgement, and after that, if the acknowledgement is not received after the timeout it comes, then again it will go to step one itself. There's another classification which is P persistent CSMA, where we can say that P stands for probability itself. Like unlike previous two models, it will check the medium, and if, it will check till the medium gets free again and again. If the medium is idle, with the probability of P sends a frame acknowledgement A, and it will go to the step 4 directly, and the probability will be 1 minus P delayed the time slot. And if after some time the acknowledgement is not received and the timeout occurs, again it will go to step 1 itself. So guys, now we are going to the third classification of random access protocol, which is carrier sense multiple access protocol with the advantage of collision detection. As the name suggests, it will just detect when the collision can occur. When the frame will collide, the medium is unusable for the duration of both, like it's a damage frame. That's why for the longer frames, it will compare to the propagation time, it will consider the wasted data. So what if the station uh, listens while transmitting? That's the solution for it. So if a medium is idle, it will transmit. Otherwise, it will, if the medium is busy, it will wait till it will get idle. And if the collision is detected, it transmit the belief of jamming signals to abort the transmission. After aborting, it will again uh, wait for the random time, and it will try again the entire process. So that's all guys. Thank you. We are going to meet in next video.